welcome to lecture one of PSTEP 160B, Applied Stochastic Processes. I want to give you in this very short clip a little bit of an overview and a roadmap for some of the clips that you'll hopefully watch and so you can kind of see what the main takeaways should be. So there are roughly 4 parts to this lecture, split up amongst several kind of segments, and I'm going to sort of move along the lines of an example, a very famous example coming out of physics. It's called the Ehrenfest-Ern model. It was originally introduced in 1907, and kind of the main theme will be for this example and for others that we'll see in this course is that in many settings you're kind of required to take a description in plain words, whether it's in the sciences or in some engineering setting. If you're working in industry or you're in academia, you're kind of always translating sort of something from plain words right into the language of mathematics, and that's essentially the tradition of the sciences and engineering. And this is something that we'll begin to do on our first example, and that will bring up sort of kind of more rigorous notions from probability, including random variables, stochastic processes, distributions, expectations of random variables, and we'll see kind of how all of these are motivated by fairly simple examples, or a fairly simple example of a natural process, and specifically this Ern model that I'm going to discuss. I'll show you one kind of more advanced calculation, something called first step transition analysis. This is sort of an important tool in the setting of Markov chains, where you're essentially computing an expectation of a Markov chain at some particular point in time. Perhaps you've seen maybe some elements of this in 160A, but certainly is a good review here, and we'll kind of go through in detail how to carry out the calculation on this particular example that I'm going to share with you. But also, hopefully you'll see sort of the framework, and you'll get some practice with this in the homeworks to the point where in the future you can kind of recognize a Markov chain when you see it, and how to carry out this first step transition analysis. And then I'm going to conclude with something that's hopefully a little bit more fun. It's kind of an example from physics, again based on the Ehrenfest-Ern model, just to place it in kind of a historical context. What is it all about? Where all these definitions come from? Why is this problem appearing in all of our textbooks on probability and statistics? And in particular, we're going to dig into the kind of the meaning of the sample space and the state space, and these are on one hand kind of rigorous definitions accompanying random variables and other concepts in probability, but at the same time they're deeply rooted in sort of well-motivated concepts coming out of physics. And so with that, I'll conclude and let you kind of move on to the next clip, and hopefully this will be interesting for you.